so that's pretty exciting, but not everyone shows up, so there's a lot of people that can't get in, so we want to make sure we're recording. And what we're going to be going over today, this is our showcase webinar with Jim Worrell, is a guest speaker today. He's going to be speaking on mobile cranes and multi-crane lifts. So what's pretty neat is that you all can obviously see each other and who all is attending. So we have about 200 people register, and we always get about half of the people, show up. So we're happy that you're all here. If you've never been here before, this is basically a hour-long session that we have Mike Parnell, our president, hosts, and he typically conducts the session, and sometimes we have guest speakers. Today we're very happy to have Jim Worrell on the phone. So if you hear anything right now, you're hearing myself, Jim, and Mike, and let's get started. So ITI is a crane rigging training company. We've been around for about 30 years, and if you're not familiar with us, we have facilities in the U.S. and we do, as well as Alberta, and we're doing a lot of work throughout North America currently and are growing into South America and Asia Pacific. We service just any industry, obviously, that conducts lifting activities. So, for instance, we have folks on the line here today from the military, from fabrication and steel erection and construction, oil and gas, you name it. So some of the companies that lean on us for their services are listed here. We really are the world leader in lifting training. That's all we do. We don't sell any products besides our training services. So this is sort of a run-through of what we've done in the past with the showcase webinar. One thing I want to point out that after this webinar, you'll have access to this recording as well as the file and this PDF that Jim's going to be going through. He's got an awesome presentation lined up. And when you go to that page, you can actually download the files for all of these other presentations that we've done in the past and watch those webinars if you missed them as well. So one thing I want to touch on there for everybody, we do have webinar training courses coming up this year as well. We had a really successful first one. We had a lift director and site supervisor course earlier this month. Those are really interactive courses. We typically shoot for about 10 to 15 people. They are paid, but they're about 3 hours, and you get ITI CEUs for attending. There's exams, workshops, and you're working directly with an ITI instructor. So, and speaking of ITI instructors, getting to the next slide, I wanted to say hello to Steve and Terry. Two of our instructors are on the line here from, I don't know where they are currently in the world, but they're online. But getting into our speakers now, before we have Jim go through the presentation, I want to introduce both Mike and Jim to you. So Mike is the President CEO of ITI, and he's really a technical expert in the industry. He's currently the ASME B30 Vice Chairman and the ASME P30 Chairman. He might touch on the P30 a little bit today. It's a new committee coming, basically a standard I think they're going to finish this year on lift planning. So, and like I mentioned, we're really excited to have Jim on today. Jim is a LSU graduate. He's been on actually several webinars before. That's how we got introduced to him. And he's a PE and semi-retired heavy lift engineer. So currently he runs a consulting firm, and you're going to see today why he is an expert in the industry. He's got a lot of experience. Just the massive amount of photos in this presentation is just incredible. So you're going to learn a lot from the presentation and from Jim's experience. So Jim, I'm going to pass the presentation over to you. Just give me 1 second. And by the way, everybody, if you have any questions, make sure you type them into the chat box. I'll be fielding those throughout, and then we're going to have a Q&A session at the end. So Jim's going to be on here and showing his screen, and take it away, Jim.
Okay, thanks so much, Zach. Just a note about the slides here. A lot of these slides are mine. A lot of the slides come from elsewhere, but the slides are picked to prove a point or expand a concept. And most are from the petrochem area, mainly because that's where the photos are. But just because everything's big and long and heavy doesn't mean that the same principles apply throughout the industry, whatever you're lifting. And although you'll see cranes with names on them from Europe or South America, I'm not advocating any one. As I said before, I'm just choosing what I need to try to get my point across. And when we talk about multi-crane picks, they're not as prevalent now as they used to be. In the past, they were prevalent because there weren't too many options. Some of those options were some of the most basic lifting devices that have been around for decades and centuries even. First, I want to talk about a few of these. First is GenPos, which are beautiful arrangement of equipment where virtually they take a pure compressive load and have tremendous capacities, but they're terribly inflexible. You also have the stiff leg derricks, which are also an amazing piece of equipment, and they work much like a crane, except their radius, their swing radius is not very large. When you start getting toward the lay legs, your capacity starts dropping off quite quickly. And then we have the guide derricks, which any of you engineers may recall from your statics classes, real and theoretical problems that involved guide derricks and other kinds of derricks. And here's an example of a guide derrick lifting and the loads being tailed by a stiff leg derrick. So this is a pure derrick operation. Also, there was a lot of inventiveness going on maybe in the 1950s, 60s, 70s, and even into the 80s, where people utilized the equipment that they had on hand. Here's a case, and this was done by a very competent rigging engineer that I know, a bit before my time, but he used GenPos atop a structure with two unmatched conventional cranes on the ground below just to set this single piece. Here's a better view of it looking from the top where you can see some of the details. Also, a lot of strange combinations were used back then. This one utilizes a crane highly modified, and I'm sure without the manufacturer's representation or approval on this. You can see they've added extra counterweight. They made several modifications here. And what bothers me the most is the fact that here the center of gravity is enclosed just with these two slings close together. And if this a gust of wind were to hit this or anything happened to it, this could easily have been an accident, but apparently it wasn't. Also, previously, a lot of pieces were erected in pieces. This is a typical example, a refinery column being erected in two pieces. And also, multi-crane lifts were popular. Here's one. I would guess this would be probably post-war, sometime probably in the 1950s from Denmark. But I do want to point out, and I'll try to point out a few things every now and then, that this excellent use of equalization on the rigging that they've used here to spread the load out properly. And in general, on two crane lifts, some points to remember are keep level. The movement or motion of one crane may affect the other. The crane should be derated. Most tandem lifts are considered critical. Some people, I've seen at least one case where someone knocked out no two crane lifts, period. And I don't particularly agree with that, but that's, and I'm sure that's what this person felt was correct, or this company. They require a high degree of planning, and if possible, try to balance the crane's percentage of chart one to another to sort of equalize the lift between the two cranes, especially when you have two unmatched cranes. The load falls need to be plumb or almost plumb throughout. The attempt is to keep them purely plumb. And in general, for every advantage gained with the two crane lift, there may be a corresponding disadvantage. Now I'm going to start with the lower risk items and sort of work up to the higher risk multi-crane possibilities. Oops. And another thing, it's an important concept to keep throughout anytime you're thinking about multi-crane picks are weights and centers of gravity and load distribution. Now this case looks like it's a difficult piece to develop the center of gravity for it. It's not really. It uses the same concept that anyone would use for a plate girder with stepped flange thicknesses, or a structural frame, or a container full of bulk material, or even a population center of the U.S., the same concepts used. I do want to point out one thing here on this vessel that's not applies to two crane picks, but notice they have tailing trunnions, which are really a bad idea, and we'll see an in-use picture of that later on. And here's the case that just happened within the last month. It started out as a single crane pick, but apparently the engineer of record did not tell the crane company where to pick up the load, nor did the crane company ask. But when they picked it up with one crane, there was severe bending of the lower cords and the smaller members as well. So apparently they've placed it down, and you can still see the lower cord being way distorted, and they're hooking up now for a two crane pick. And I don't see any evidence of tie-off. Maybe there is. I don't know. Here's a typical two crane pick, two crawlers picking up a large vessel just to pick up off of the saddles. Here's a case where two telescopic boom cranes working side by side are offloading a kiln section from a transporter. Now, I do know that some people who say that all two crane picks should be critical lifts make an exception for offloading or loading onto trucks, which I tend to agree with, although the lift should be carefully planned regardless. And here's a situation where two cranes opposite each other are loading a generator onto transporters. Now, when you're working opposite like this and the hooks are closer together, any harsh movement in one crane might affect the opposite crane slightly more. Another good use of two cranes is this example where two crawler cranes are walking a PIPERACK module onto a barge, and this is on a concrete and landfill dock, and they've also, so that's why you don't see any mats. This dock happens to have a 10,000 PSF load rating on it, and it's very hard. Here's another case, setting a horizontal tank on the foundations. One thing that bothers me, though, is that they've got the rigging so close to the end here that anything that could go wrong, they could have easily lost the load. Apparently they didn't, but that possibility still remains. Another good use for two crane pick is, here's a vessel being offloaded from a barge for highway transportation. And to get it rolled to the right orientation for highway transportation, they used rolling sheaves or snatch blocks is an option too for doing the rolling, and it can easily be rolled with the whip line. You don't see the whip line here because they've already got it into the orientation needed for transport. Another typical horizontal two crane pick is setting of beams and girders. And sometimes on a load like this, one end will be placed down before the other, which is fine, but there are rare cases where, especially if your center of gravity is way offset one way or another, you could actually wind up getting more load on one crane than you did before. But I want you to notice too that this outrigger here, where it's so close to the toe of a slope that's recently compacted backfill, and their matting is minimal. It seems that the lift's going to be made okay, but it's still a tricky situation there. And that same concept could apply here. This is where you have two cranes. One end has been placed down and they're getting ready to sit the other end. I don't know what the distribution between the cranes were, but I'm sure this reliable contractor calculated the load in the cranes before and after the one end was set down.
Jim, this is Mike Parnell. This is an excellent observation of where the crane on the left, if he lands the load, then the crane towards the right may end up with 90% of the load. I mean, in that situation, right before he gets his end set down.
It all depends on the CG, and all of it, and it's totally possible. You could double your load in some extreme cases.
Right.
So here's an example too of two crawler cranes setting a pedestrian walkway. The crane on the left is stationary, and it can swing. The crane on the right swings and is able to walk with the load, making for a smooth operation. Another example are two cranes, match cranes with a long boom, and they're crawlers, so they can walk right in simultaneously in with the load to set it properly. This lift was best for two cranes because of the multi-lifting lifting points required. I'm not sure whether there are 8 or more lift points, but one crane could do the job, but it would take quite a large crane with a lot of headroom to get all of your special rigging hooked up to it, and you'd increase your load with the weight of all the rigging. This lift, although it's a two-crane pick and it's a horizontal lift, the cranes really can't see each other, so the signalman has to be very skilled for this. Also, it's high, so they need a second person to direct up on the roof. Now here's a very good example of where a two-crane pick will usually be preferred, rather than trying to put this enclosed conveyor section at the desired angle and have to deal with chain falls come along, special rigging that may or may not be properly calculated. This is a case I've only been involved with once, and I never want to be involved with one again, but this is where when cranes were small, or smaller than they are, much smaller than they are now, and this 75-ton vessel had to be moved from roadway into an enclosed area inside of a refinery. So what happened is this one crane, 200-ton on the right, took one end, and a 60-ton in the street picked it up, transferred the load midway to 140-ton to bring it into the enclosed area. The problem was that if this had been dropped, the explosion would have made Worrell news, because there's a 600-pound ethylene line there. Another concept with two crane picks is frequently one has to swing through, sometimes on land and more frequently on docks. But in this case, much care has to be taken to make sure that there's no interference with the vessel and the crane, and that the booms aren't going to interfere with one another. One has a jib and one just the boom proper. But I did want you to look at how good of an outrigger layout they've got in all cases here. They've put a lot of work into the ground bearing considerations for this lift. So I'm going to stay on docks for a minute here, because docks have several unique properties, whether they're structural docks or landfill docks. Nearly all docks are going to have a fender system of some sort, which is going to increase your radius somewhat, maybe 3, 4, or even more feet on some docks. And if it's a structural dock like this one is, the engineer for the port or the dock facility is going to have some fairly stringent requirements as to what the cranes can do, and you may have to back up a bit. With these crawlers, they're not going to have to worry about the swing through, because they can back up out of reach with the load and be okay. Now, here's a case where with two lattice boom truck cranes lifting a reactor component, the placement of the most loaded outriggers are going to be dictated by the engineer to be as close to a column line as possible. So this pretty much restricts where the cranes can be set up. This was what I was involved with some years ago, but it would have been better if we could have had more room between the two cranes, but we would have gone out of radius on one of the cranes had we done that. And here's a similar case where it's a landfill dock, but it was really radiuses of the cranes that caused the cranes to be closer together. And another swing through, and you can see from this picture how the crane operators really don't care for this kind of lift too much, because they're sitting there looking at this vessel right in their face the entire time. And unfortunately, the railroad track is in the wrong place to put an outrigger, and railroad tracks are always the most fortified part of any dock if it's a structural dock. I'm showing this picture because this vessel happens to have a center of gravity close to the bulb end, so almost all of your weight is back here. So the larger crane, you'll notice he's picking way back up here, so they have to be very careful on the swing through to make sure that there's no interference between this end and the crane. So I think they're going to lead with this end and come on across here. This is a little bit more complex situation with these mooring piles. 4 to a barge. They're 21-foot diameter and 270 tons, so they're pretty hefty pieces. And the 2 unmatched cranes here have to do a lot of shuffling, and also the barge has to be shuffled around to make sure all of the yellow ends are lined up. In this case, this shows the outside or the outboard piles being loaded on, where the cranes can work in the conventional mode with the 300-ton truck crane and with the Skyhorse here. But for the inner ones, which are actually the first ones to be set, the crane switch places or with the more mobile truck crane moving to one end, and the Skyhorse actually hooks up the counterweight, which is what's called a sky derrick, which gives him additional capacity. And we get a little more higher up the risk scale here when we go with vertical vessels, and here's a near ideal situation where 2 totally matched cranes are picking a relatively short reactor with relatively short booms. I do want to point out again the excellent use of equalization on the rigging here. And here's a picture showing 2 unmatched cranes lifting a taller refinery vessel, and another with one, but the difference is this one has lifting lugs down on the shell, which results in 2 key things. One is it reduces the tail load considerably, but the second is a disadvantage, where anything above the lift points may interfere with the rigging, the block, or the lower block, or even if it's tall enough, the upper block. This is let's see, this tower is 206 foot tall, so it's a pretty tall tower. This concept's also very useful for flare stacks, and you'll see this with flare stacks a lot, because some of these flare stacks get up to 300 feet, maybe more in some cases. And here it looks like they have some dress out here, but not too much, that could interfere with your load fall. The key point is to make sure your lift points are always above the center of gravity, or then you've really got problems. I'm showing this picture here because in today's world, this would be a much better lift if it were a single crane lift. And I say this because the 2 lift points are so close together, there's a good chance of the booms interfering with each other. But it looks like it's well planned and things are going well. This one's a little bit different. This looks like it's a uniform vessel. This is a used vacuum tower that came from Philadelphia to New Orleans, but due to the internals, mainly cyclones, the load distribution on the lift lugs was 57% and 43%, So we place the larger crane on the heavier side and the smaller crane on the smaller. It's rare to have a vessel like this, but it does happen. Here's a case using two guide derricks on crawler cranes lifting a large cat cracker reactor. And I want you to note that the two cranes are tied off here, which actually acts as guys. And this concept of tying the two cranes together limits the cranes to some degree. But here's a case where the two cranes are tied together with an inverted lift beam, which enables one to make adjustments. Here, the larger crane, or the crane at the shorter radius, depending on what the situation is able to more equalize the load between the cranes by this simple method here. And we'll see more pictures of this as we go on. With domes and rings, the inverted beam really helps a lot. It increases capacity by reducing the boom length, and it increases capacity by reducing the radius of each crane. But there are some disadvantages involved with that also. Namely, the swing of each crane is somewhat limited. They can't go 360 or anywhere close to it. And the limited rotation of the load could be alleviated with a swivel, but I don't see a swivel here. And the communication and signaling requires a higher degree of planning and ability. This is a more sophisticated lifting frame connecting the two cranes. NASA has this one. It's got three large load cells on it. You can see one here and one here. Plus, NASA, being NASA, has several measuring devices here and here where they are measuring everything, including the amount that the crane booms deflect during the lift. And I think for the larger crane here, they calculated something like 18 inches deflection on the top, which we really don't see from the ground. Here's an example of a pressure vessel erection with two unmatched cranes with the inverted spreader beam, but this is on a vertical piece rather than a horizontal piece. But this concept doesn't have to always be used for pressure vessels. Here's a press in Germany shown using the same concept of the unequal cranes and the uneven beam. Again, we're connecting two cranes here, but in this case, you have a little bit more swiveling capacity because the second beam is added to the bottom. Now, that beam could have been added because the lifting lug requirements required a vertical lift rather than allow a lift on an angle. I chose this picture because it looks so tight. I'm not sure where this was, but they're almost two blocked with their cranes. The beams are pretty bulky, and they're pretty close to the booms, but if this was a well-engineered lift, and I'm sure they knew what was coming up. This is an old picture which shows an extreme example of the inverted beam between the two cranes. The crane on the right is very small. I don't know how small, but it is. I'm going to work my way into tailing, which I'm going to cover with quite a few slides, but I'll start it off with what I would call flipping. And in this case, a common example of flipping are what I would call taking a short piece and going from one orientation to another, in this case the horizontal to the vertical, and a two crane tilt-up fits the bill here pretty well. Secondly is flipping a cone section, and I know there are other terms for flipping. Like most terms, are regional and can change throughout the country or around the world. Another case where this is a crane pick lifting a bucket wheel going from the horizontal to the vertical. And we go into tailing, which I would define as taking a longer piece and going from the horizontal to the vertical, or if you're taking down a piece, going from the vertical to the horizontal. But tailing requires a higher level of planning, engineering, communication, and execution. And the load falls must be plumb. And this takes a little work, because as you change the orientation of this vessel or any piece in the vertical plane, the distance between your two hooks is going to reduce. And one should work slowly, perform only one function at a time with each crane. That doesn't mean that both cranes can be doing one activity at the same time the other is. In fact, that's almost essential to do it. And as we'll see, the load distribution varies throughout the lift. And the signaling here is of most importance and should be performed by only one experienced person. This is a typical tailing chart showing how the load changes over the degrees, and these are degrees from the horizontal. This is approximately a 700,000 pound vessel, but the same concept is true for lighter pieces or for any other load. And although the geometry may change for the piece of equipment, the curves are pretty much going to look like this. You'll see as the main lift crane as the angle is going up, he gradually gets more load until it jumps up real quick. And the opposite is true for the tail crane, where his drops off very quickly. And if it's going from the horizontal to the vertical, at some point, probably over 80 degrees, the load's going to go to the plumb position by itself without the crane helping. Here's your classic example of tailing with a crawler crane. The lift crane basically is going up with the load only, and the tail crane is walking into the lift crane. Now point out the dress out here, because for a general safety aspect it's very helpful, because it saves people working at height. But from a lift safety perspective, it's not so good, because it, number one, increases the weight of the load. Number two, it tends to cause interference with rigging or load fall or blocks. In the past, and even some now, tail lugs or any kind of positive connection for tailing were not considered. So usually one would have to use a choker hitch to do that. And you can see here the blocking that they've placed under the choker hitch, probably to provide more friction, but more often than not this blocking is going to fall off somewhere during the lift, and there's going to be some impact loading to the crane, especially the tail crane. And when that happens, usually there's some shuddering and funny noises where all of the people watching the lift who don't want to be involved disappear quickly. Also, here's another case with the single choke tail load. You can see as this load becomes more vertical, the danger to these nozzles would increase. And these are probably 1.5 or 2 inch nozzles, and this sling could easily damage the nozzle here. To me, the most perfect type of tail attachment is the simple tail lug, either 1 or 2 lugs, and it enables the tail crane to get it a close radius, and also to keep it out of the operator's face and out of the boom. A tail crane can also work behind the load if it's a fixed crane, but there's some limitations. If he booms out and runs out of capacity, 2 things have to happen. Either the main lift crane has to boom out more to compensate, or you have to put the load down and let the tail crane reset up. And many owners or engineers do not want their piece of equipment set down temporarily because they fear some damage to the structure, which in some cases may very well happen.
Jim, if I can interrupt you for a minute on
yes,
the
please.
slide that's on the screen here. If you go back one slide, I'd appreciate it.
This one, or one more?
One more. Yeah, there you go. It's one with the yellow slings on the framework on the tailing crane.
Well, wait.
No, let's go forward a couple of slides there. And your computer's got a bit of a delay. Yeah, let's go forward.
That's going back, but okay, I'm going to.
Right there.
This one? Okay.
Yep. Notice how the slings are basketed around the bottom structural section there, maybe tubing or it could be I-beam, but rolling slings, rolling a load in a sling basket hitch like that is really, I'm sure you'd agree, really dangerous with the ability for cutting and friction on there, and it would be, because I mean, it's got to turn 90 degrees in the belly of the basket hitch, and it just appears to me that those are simply basketed to the framework, and it could be really, I guess, very fortunate that they were able to upright that without having the tailing crane slings to fail.
I tend to agree. I would never use a synthetic sling in that situation.
Yeah, yeah, they were very fortunate.
But on the plus side, they're actually using rolling sheaves up top to provide equalization, so that's good.
Yeah, absolutely.
Okay, going on to the next slide here, because of the lift, the tail lug location on this module, the contractor found it best to work to tail from the side to not have the tail of the load in his face and also get a better radius. And it looks like it's a crawler crane. Yes, I see the tracks in the corner. So that makes it easier. He can walk with the load. Here's another extreme example of that where it's better to tail from the side rather than tail from the end. And one more case, because it looks like whatever this is, it appears to be that this is a roadway or something of some importance marked here that they do not want the tail crane to be on. And this is also a two-crane lift as well. Here's a situation that I like to do if there's any chance of doing it. The tail crane is back here. It's a red and white link belt, and your main lift crane is here. But when you pick up, the lift crane is going to basically do most of the work. He's going to be picking up and swinging, while the tail crane back here is basically going to stay in one spot and just hold on to the load pretty much, boom up a little bit or make some small adjustments. And here's a picture of it a little bit further up in the air. And if you have the room, it's a nice thing to be able to do. This is kind of a special case here. This is a 202-foot long aluminum vessel weighing 202 tons, and it was made in Germany. And when they were first loading the vessel out, it broke in two pieces when they were loading on a barge in Germany, and the Germans were quite embarrassed about this, but they decided to redo it, and they took off the skirt, which is the section that the vessel sits on, to make it shorter. And then two engineers from Germany came over, and I met with them at a hotel room in Mobile for a full day. We made models and calculated, and they figured out what we were going to do to keep anything from happening to this during the upending process. And we decided that we'd use two pieces of rigging here, one connected to the base and one cradled here in the about 20 or 30 feet up. And at a certain degree, this rigging would slack off, and this rigging would take over, if you can see that yellow there. Now here's a picture of it. It looks like it's right at 45 degrees or pretty close to where the transition point is, and just a few degrees more, you can see where it slacked off, and we went ahead from there. Another situation with tailing too, where you have enclosed spaces. This was a fairly large tower back when, I'm going to give you the dimensions here. The tower was 232 foot long and a 230-ton tower. It had to be brought into position in two pieces and welded in place, and then it had to be picked up with the bottom going under the pipe rack there. And here's a picture of it actually, so you can see how long it looks. And you may note that the crane is using the side hitch to pick it up, which means that when the vessel's vertical, it's not going to be hanging plumb, which makes for another problem that we're not going to discuss here. But during the tailing, just to get the tail end out from under the pipe rack, we had to excavate about 3 feet to do that. Here's another enclosed area, and there's another little lesson here too. This is taking down an existing pressure vessel. We asked the client, are there any solids in there? Are there any liquids in there? And when we got to this angle in the process of coming down, you can see the wetness here, but water gushed out for at least 30 minutes at a high rate. I don't know how many gallons there were, but luckily we had the crane capacity, an excess capacity at first to not have a problem. But it was still very difficult trying to tail down in this tight area because we had to come out through here, and the tail end, or the head end, had to come on this 2-axle 16-wheel dolly. And here you can see it in sort of an intermediate stage here, and the tail crane had to work its way out of there as this end came to the dolly. This picture shows a vessel with what's called a top head lifting attachment, which you might see frequently on heavy wall vessels that use body flanges instead of traditional standard flanges. But what's good about this lift is they have 2 tail lugs, which gives you a triangle of stability. Here, 1 tail lug here, 1 here, and 1 here make a triangle. Now, if this vessel were to have a tail lug, like this one, and if you had anything on the side, any dress out or any protuberance here, you could have the possibility of a torquing motion, which you do not want. Now, here's a case where, because of this large flange here, that situation does exist. And this wasn't the only reason why this was a tough job. One is you've got power lines here that knock out your access. The fence line here is over about a 15-foot drop to grade. The main lift crane has limited travel because of severe underground activity, and the foundation is here. Also, the tail lug is high up, which means that the tail crane is going to have a larger tail load, and he doesn't have much room to work around here. And one more thing too, the client insisted on putting this top platform up here, which means for our rigging we had to have a spreader beam up here that would miss this, and also take into account the fact that we knew that the stack was not going to hang plumb because of this big nozzle here was going to knock it out. So, and here we show the slings passing by that upper platform. This is another real-life story, and it was a mistake on my part, where this 300-ton reactor should have been a pretty simple lift. And you see right here some low-level power lines that basically were just going to a service drop for a light, outside light over a warehouse door. But I did not include in the bid a stipulation that the client would remove this line even at our cost. the client said, no, to be fair to the other bidders, you can't take the line down. So that meant we had to put a tail crane on the other side of this pipe rack far enough back to where when he boomed down in tailing that he would not hit the rack. It's a small rack, and it's probably actually a cable tray rack rather than a pipe rack, but still it was an unnecessary expense and aggravation that we had to go through. And my lesson was never assume anything anywhere. These aren't very good pictures, but this contractor apparently had a weak tail crane, so he compensated by putting the tail crane right next to the foundation and the head of the coal box over here where the two stronger cranes could pick up and swing it into a vertical position over the foundation. And here's the second picture showing just what they did. And I'm showing this picture not because it's a good picture, because there are two things that I think that they're doing wrong in tailing, and I may be wrong because I don't know anything about the lift. Number one is I don't see any need for this much boom in the tail crane, because if you had a lesser boom, you could have a shorter radius and have more capacity for both of those things because of the radius and the boom length. And also, why are they tailing so high in the air? I can't foresee a reason for doing that, because I've always learned and kept to the adage that you never do anything unnecessary with the lift, and you always try to keep your load as close to the ground as possible until absolutely necessary to raise the load. Now here are two cranes being used to tail with. And in this case, you've got a bolt-on tail frame, and because there's not too much room for two cranes to crowd into a single lift point, they're using an inverted lift beam again. And again, you can see that it's offset because this is a larger crane than this one is. And it works out okay, but you can see the oiler on this crane is constantly looking out to see that tracks don't interfere or that they're pretty much going in line. And they are doing a good job of keeping the lift beam level. Here's another case of exactly the same thing, but using an inverted spreader beam and two highly mismatched cranes, where the larger crane is actually right behind the vessel and the smaller crane is walking along the side. I mentioned earlier about tailing trunnions, and in this situation, using two telescopic boom cranes in a fixed position, the trunnions work fine, but you can envision that if you placed a crane back here behind the load that tried to tail with the trunnions here, your blocks and rigging would get into the load quite quicker than you'd like. Plus, you'd have this nasty point looking at the crane operator all the time.
Jim, let me, if I can ask you a question, do you run into many circumstances where your trunnions, when we're running a basket hitch around, where the trunnions, are they pretty robust with the sling and contact there, where they're not really ripping wires too much or sawing into the trunnion very much? A pretty good interaction between the slings in your experience?
Most of the time, what I've seen people use is either heavy grease bags, or a Teflon or similar material lining the trunnion to where you'd have better
lower friction?
Yes.
Yep.
And and sometimes you're not tailing with a crane, but with a tail frame. Usually this is for your much larger pieces, and one disadvantage of the tail frame, this is just one of many kind of examples, is that you don't have much flexibility. The tail is pretty much in a straight line, so you have to be aligned nearly perfectly to make it work. If you use this example where they have the tail device on transporters, you have a little bit more flexibility. This is something that I've used a few times, and I don't see it very often. But if this was for a complex tailing operation where there wasn't much room, and the tail crane had to make several movements, and this was coming down with the vessel. So when the crane started, he had to swing, then walk, and swing, and walk, and so this compares his capacity versus based with the load that he's got at any given point during the tailing operation. And I've used that 2 or 3 times throughout my career, and I found it very helpful to explain to the crew and to the client what was going on. Now this is an accident, and it's a tailing accident even though it doesn't look like it in the picture here, but this is a homemade crane, I guess late 60s or early 70s, that has no outriggers and no ability to swing. And from what the people in the plant told me was that the tail crane was just like it. And I assume the tail crane's off the picture somewhere here. And so they got in a bind somewhere, and neither crane had the capability of swinging. And so the whole business went over, vessel, cranes. And luckily they shut the plant down because the boom tip went right through the control room. And I do want to take a little time just to talk about rebar cages, which I don't like because they're non-rigid lifts, and I have to give some credit to the crews for having to fool with these, and just based on their experience, they really do a good job. But if you took a closer look at a lot of these operations, you would find that in addition to maybe the rigging not being quite strong enough, you're going to find that the crane is not operating according to the manufacturer's recommendations on drift, which is if the load fall is going to or away from the crane in the plane of the boom, or side load, which is perpendicular to the crane, or the limitations on the use of 2 hooks. And sometimes, unfortunately, this happens to be the result. Now we go into multiple crane lifts, which I define as more than 2 cranes. And I'm saying except for roll-ups, lifting up and down should be the only actions allowed. And take into account that there has to be some minor movement for modifications, a little shifting here and there to get everybody plumb, everybody level. And derating the cranes is essential. I don't know what that amount should be. It really depends on the owner, the contractor, whoever's doing it, what the risk is assumed to be, maybe 75%, 70, 65%. I'm not sure. Here, your planning and communication and signaling are most important, and the determination of the accurate load distribution is necessary. In this case, it shouldn't be too difficult, but on a, say, an offshore platform or something like that, it would be much more difficult. Historically, here's a 3-crane pick that is made because that's all the cranes they had at the time. I don't know where this is or what year it was, but you can see the 3 cranes and 2 are linked together with a inverted lift beam. Here's a 3-crane pick that's mandated by the pick points on the plane proper. And here's another good example of a 3-crane pick where you're essentially just going vertically with a little room for flexibility. And here's a more advanced concept of that where a entire roof structure is being lifted. Then we go into the offshore roll-ups where multiple cranes, and they're usually going to be American Sky Horses because they can walk and they have a good capacity. The coordination and signaling here is naturally of much importance. Here's a more well, let's say a larger version of that. which takes much more planning. I had mentioned earlier about what happens to one crane affects the others. This is a good example of that, and I'll show you a few more pictures of it, but you can see here the cranes are falling apart, and I assume these are boom lacings. I don't know, it could just be scaffolding components, but I'm just guessing that they're boom lacings. But I'm going to start off with the accident in the first stage to the left. This is a picture that you just saw, and this is where it finally ends up. And in conclusion, in general, the use of multi-crane lifts has decreased in recent years, but the need for such lifts remains. If a multi-crane lift is the best solution, the planning and execution must be elevated to a higher plane. This includes an emphasis on weight, center of gravity, and load distribution, as well as planning for all movements and situations, communications, and signaling. And remember, go slow, keep it level, keep the load falls plumb, and attempt to minimize executing more than one task at a time with either crane. And Zach, that's the end of my presentation.
Perfect. Jim, thank you so much. I hear the crowd going wild. We've gotten a lot of comments coming in. I'm actually going to pass the presenter over to Mike so he can help with the Q&A session. So let's see. We got I don't know if you saw the comment board pop up. There's a lot of great insights and questions for you. So I'm going to shoot with the first question, and if you don't mind. And Jim, how we can handle this, I guess, is I will read the question off, and you can take the first crack, and Mike can chime in too, and you guys just have a conversation about it. And everyone,
okay, good.
If you have any questions, yeah, and if you have any questions, everyone, please sure to use the chat box to the right, and we'll get going on that. So before I read the first questions, I want to maybe some quick highlights on the last few comments would be helpful because they're referring to the last few slides. Joe Collins wrote, the problem with trunnions is that they are not a secure connection. I prefer pear-shaped links that can slip around the trunnion. And I know that Joe and Ken were both referring to a later slide, so I just want to comment on that and share that with you guys if you had any thoughts.
Well, if this were a presentation on rigging, I would have had a slide showing exactly what Joe had in mind there, but because I do like that concept, you don't see it that often, but it to me, it's the best.
Yeah, Mike, looks like you're drawing something there. Did you have any comment?
Yeah, I think Joe's got an excellent idea and approach, and Jim uses the same, but it would be shackled in with a large master link, some suitable hard link that would accept the trunnion contact surface, and you wouldn't really need to worry about abrasion or other issues related between scrubbing and making the 90-degree turn. So those are excellent way to mitigate the issue related to some of that damage and sawing effect.
Yeah, good point. Well, thanks, Joe. And you guys, I'm sure, saw Ken's comment. He said yellow 77 wire pulling lube, very slick and dissolves with hot water, environmentally friendly. So that he was referring to a slide that you had, Jim, there.
Well, I guess that's a comment on the your question concerning what to do with trunnions.
Right, grease or lubrication of some type. Yep.
Yeah, good.
Okay.
Let me hop into some of the, and Joe just mentioned to you guys that also the sling can slip off if there is any slack. So obviously another issue around trunnions. So we had a question come in from Dan early on in the presentation, and he asked basically, and this is, you got to go back in the slides maybe a little bit to remember this, but tailing cranes can have excessive loading at the near vertical vessel position. What would be a good crane capacity percentage for tailing cranes?
I would say that the tail crane should have the same limitation on capacity that the main lift crane would have, depending on the owner's or the contractor's own specifications. 85, 75, whatever it happens to be, 80, 95.
Okay. Mike, do you have a comment on that one?
No, no, I think Jim's hit it on the head. You know, it's going to be set up in their procedures, and it's whatever they've prearranged and decided, and they're going to measure it all out to confirm that they won't have to boom down, or they'll have to crawl up to the load in its near vertical position to assign that. So that'll all be determined in the pre-planning process.
Okay, great. This question came in seems a little tricky to me, but Ramesh was asking, is swinging possible after lifting a load with two 1100 series American Hoist guy derrick cranes?
Swinging is, you mean after the load's been set?
I think it was right around, Jim, when you were talking about, I think a boom has to, when you have dueling booms and one boom's got to clear the other one first. I believe that's when he wrote that question in. So swinging inside or close by the other boom. But Ramesh, if you're listening still, please clarify. But I don't know if you guys have any thoughts on that.
I'm just not sure what the question is, and I'm having.
Yeah, I think he's wondering, is swinging possible while in the air with two, and then he called out a specific crane type.
Oh, okay.
So I don't know if we need any more information from him or not.
Okay, now that I see it written, I thought you'd said guy derrick, but you said the sky derrick. With the sky derrick, you have a little bit of swing, but not very much, because you only, in effect, have one guy in the back. So I could go maybe 10 degrees either way or so, but it's just enough swing to compensate and get where you want to.
Okay, awesome. Let's see. Ryan asked, what is the minimum distance of the anti-2 block from the boom tip?
That just depends on the crane.
Okay.
Jim, have you been in a circumstance where they've disengaged the anti-2 block device for a critical lift based on headroom?
No, but I've been in some situations where it got pretty close.
Yeah, yeah. It's really not advised, I would think. It's as a general rule. I mean, it's because we get so focused down at the load level and all the things that have to do with the load and not contacting the boom and making sure the hoist lines are plumb and all those things, and to also be trying to worry about having disengaged an anti-2 block device and to make sure we don't 2 block the thing. That just compounds everything 4 or 5 times, I think. So it seems like it's there for our saving ourselves, and probably very ill-advised to try to disconnect that just to get another foot or two of lift.
Yeah. Yeah, good point. Well, very good. I think that's it for the questions, unless anybody else would like to chat in some other questions.
You know,
Yeah,
I've got a question for Jim. Jim, you were probably a part of the American Society of Civil Engineers. They did a crane operations book a few years ago, and I was curious. I was looking for it the other day, and it looked like it had been removed, or not retracted, but maybe removed for rewrite. Are you familiar with that? You're a member of ASCE. Yes,
well, I did a lot of that, and in my opinion, it never got finished. It was published to meet a deadline pretty much, and it had some good stuff in it, but there were some things that were maybe hard to understand. I've got copies of it.
Has it been pulled off for circulation or retracted, or I mean, is there a public availability or its status? Do you know?
I'm not sure. It was never really published as such. It was part of an OSHA Susan Harwood grant, and it was supposedly something to be developed on a future grant, and it never got past the first stage.
I see. Okay. All right. Good. Well, we'll look for it in the future if it becomes available. So let's see. Zach, any other questions?
Nope, I don't think so. Oh, wait. Well, I guess Bob, hey, Bob Berry had a question. He was wondering if there's a formula for tailing capacities.
Is Bob an engineer?
Is Bob an engineer? I don't believe so. I think it's Bob Berry from Sims Crane down in Florida. No, I do not believe so, Jim, but I apologize, Bob, if you are.
Well, what it is, the geometry of each piece, let's say if it's a pressure vessel, it's going to vary between with the CG, the diameter, the location of the lift lugs, the location of the tail lug, and it just has to be run out for any particular case, and there's not really a formula as such, although one could make formulas for several different general types.
Jim, if I can comment, there in the new P30 ASME P30 lift planning document is just went through public review, and there are 10 consideration points for single and multiple crane lifts. And we actually did not state not state percentage for a single or multiple crane. And really, I think you've hit on it. Is it's going to be up to the crane owner, the project manager, project superintendent, crane manager, and it's going to be something, first of all, an engineering decision, and then a team decision with the operators and everyone else, because you've also got to get buy-in and somewhat and some acceptance of capacity. But we opted not to put a percentage in there because we didn't want to paint the industry into a corner to stay within some specific percentage. I mean, there's probably, and I'm sure you've been on cases where you've had say 2 cranes are both at 90% or 92%, or one's 95 and one's at 91 or something, and we don't want to put a percentage in published print because even if it's a should, sometimes people take shoulds into shalls, and if we say publicly shall not exceed 75% or should not exceed 75%, a lot of safety folks around the country will start to use that as their mandate, and we don't want to hamstring the industry by getting a percentage there. I think Jim's absolutely dead on about, hey, it really needs to be the project decision and what they can live with, and they'll make a lot of consideration points that will affect that. It could be wind, ground and soil conditions. We believe they're solid. Compaction tests, everything's been done, but it may be just not the fuzzy factor that you just don't feel all that good about going past 90, and that may be their limit. So I think Jim's very accurate in being able to say you don't want to impose a specific one and start building that in people's minds. There's going to be issues that come at you from all different directions that may affect that, and you don't want to paint yourself into a corner you can't get out of.
Yeah, let's analyze the risk. If you're in a hazardous environment like a refinery or chemical plant, it may be different than something in a open type situation.
Right. Risk will drive it, won't it, Jim? That's really the big part. Yep. Okay. All right, Zach, anything else?
Yeah, I want to share what Ken wrote from BP. He mentioned MaximumReach.com has a calculation program for free, and it's for uprighting loads. So they have, I mean, obviously they've built it out a little bit, and I don't know if I've heard of that. Mike, have you heard of that site?
I have, yes. Mm-hmm.
Okay, cool. So, and another comment Eric had was, there was a graph that Jim showed on tailing capacities earlier, and how can he pull that up. And I want to let everyone know that you'll get an email today with a link to basically access the recording of this presentation as well as the presentation Jim went through. So we really want to appreciate or say thank you to Jim for doing the presentation and making it available to everybody. So tons of good resources in that presentation, and you can also download all the other presentation files like I mentioned before. So with that being said, Ryan, I think asked a couple other questions we can probably answer, and that looks like it's the rest of it. I'll just cut it off there. So Ryan asks, is it necessary to have an emergency rescue plan for every multi-critical crane lift?
Wow, and I don't. To me, I would just say it would be a function of the situation that you're in.
Yeah.
I'll comment, Zach, on that. And that one of those 10 consideration points that we mentioned about under ASME P30, it is the 10th point is having an emergency action plan on site, but it doesn't have to be with the crane and rigging crew. It actually is a site emergency action plan, and the crew needs to be informed what is it. Because as Jim mentioned, heck, you could have a gas release or chlorine release or something else that you've got to evacuate, maybe even with the load suspended for some reason. And I think, and Jim and I would both be in agreement, we don't want to be emergency action planning for crane failure, right? That way, if you don't have, I mean, we take contingencies into effect, but you know, obviously we clear people out, we stop any production flow lines that are necessary that can be stopped, de-energize power lines whenever and wherever possible, clear out buildings as needed, but you know, you don't plan for failure, but you are respective of the existing site emergency action plan based on a general announcement and for the crew to have to react to.
Anyone who does a good lift plan should always keep in mind and make it a point to think of anything that could possibly go wrong during that lift and what you've planned into the lift proper to avoid that.
So you're planning out the issues, right, Jim?
As much as you can, and if it's beyond your control, it may be under somebody else's control.
Yes.
That you can work with, like the owner, if you're a contractor. Sometimes the owner and the lifter are the same, or the contractor and the lifter are the same.
Right.
Okay. Terrific. Well, the last question I'll field, I guess, is straightforward. Ryan asks, are boom trucks allowed to do tailing lifts or tandem lifts with?
I don't see why not, as long as they're within the range. I mean, they're basically cranes just like other cranes. I'm sure it's going to be limited, but it's sure better to tail than just put it on the ground and try to
drag it.
Yeah, I was looking for that term.
Sure, if it's within capacity and everything, it's absolutely. We don't want to, as Jim said, the alternative is to drag it up to the head crane, and you don't want to side load or snag the load, or, I mean, all kinds of bad things can happen if we don't help it a little bit. So,
excellent. Excellent. Well, thank you guys both very much for your time today, and I want to thank everyone that's still online. Thanks for coming on, and I hope you enjoyed the presentation. And we just really, everyone, please give an email out to Jim. Just thank him for the presentation that you have access to now. It's a big help, Jim, for the industry and for everyone's knowledge and education. So thank you for joining us today.
Great job, Jim. Thank you very much. Look forward to everybody be visiting with us again in the near future.
I enjoyed it, and thanks for the support.
All right. Okay. Thanks, Jim. Thanks, everybody. All right. Have a good week.